Hello everyone, welcome to my channel Regular Learning Academy. I am Dr. Krishna Sarkar, Department of Electrical Engineering. Here in this session, I will be going to discuss about Introduction to Microgrids and Power Quality. So here we will be having little brief idea about why we study microgrids and power quality. This lecture mainly for UG, PG and PhD research scholar students. So our topic's name, Introduction to Microgrids and Power Quality. This is Power System Series, Lecture 1. So next, what is the overview? Introduction of the microgrids, DCs and DFIGs. Microgrids and renewable energy. Types of microgrids, type of DCs, basic components in microgrids, importance of harmonics for power quality, undesirable effects related with harmonics, power quality issues, power quality parameters, the wind turbine generator types microgrid, conventional DFIG with wind-based, advantage and disadvantage of microgrids, future direction of microgrids. This is our overview. So next, what is microgrid? Microgrid is a localized grouping of electricity generation, energy storage and load units that normally operates in synchronism with the traditional centralized grid, with the flexibility that the unit as a whole may be disconnected from the central grid and may continue operation as an isolated small grid, hence the name microgrid. Typical microgrid with renewable energy resources. So what is the resources for microgrid system? First, fuel cell, battery, solar energy, wind energy, local generation, where microturbine, natural gas, nuclear power, biomass, and another ultra capacitor energy storage device. This is doubly-fed induction generator. And this section mainly protection purpose, and we can use FATS device which can control the voltage sag, swell, flicker, any type of power quality solve this system. And next section, this is utility grid, which is connected one connector and smart meter. So next types of microgrids. There are most important different type of microgrids. Those totally on one location, similar to a conventional utility consumer. So number one, customer microgrids. Number two, utility or community microgrids. Virtual microgrids, remote power microgrids, and campus environment microgrid, community microgrid, remote off-grid microgrid, military base, new microgrid, most practical commercial and industrial microgrids. These are all types of microgrids. And another section we can discuss with source respect what is the microgrid and types of microgrids. So with source respect, the microgrids are mainly three types. Number one, DC microgrids. This is the architecture of the DC microgrid systems, where DCs, which is connected DC to DC converter, and this is the DC bus. And another AC distributed generation, where AC to DC connector, which is connected DC bus. Another is what energy storage, which is connected also DC to DC system, and here DC and AC both are connected with respect to load. And another section, this is utility grid, and this type of microgrid, simple, reliable, and energy or efficiency is high. So next, AC microgrid systems. This is the AC microgrid systems, and here the main sources are PV cell, which is connected DC to DC converter, inverter, filter, and then microgrid. Another source, fuel cell, DC to DC converter, inverter, filter, and next microgrid. Another section, battery, DC to DC converter, inverter, filter, and microgrid system. Capacitor, which is connected DC to DC converter, inverter, filter, and microgrid. And next section, wind turbine generation, or which is connected wind turbine controller, filter, and microgrid systems. And in this section, load side, mainly linear or sensitive load. Sensitive load, for sensitive load protection purpose, we can use FATS controlling device. And this is utility grid, which is connected metering with metering or one connector. And also this type of microgrid, very simple, reliable, and efficiency is high. And this is the hybrid microgrid system. Mainly this section, hybrid microgrid system, where the sources are micro turbine, Doubly-fed induction generator, and this is also smart Doubly-fed induction generator. This is PV array, and this is proton access membrane fuel cell stack. Another side DC microgrid, which is source where sources are Doubly-fed induction generator, which is connected rectifier, and rectifier AC to DC converter, and another section PV source and buck boost converter, and this is mainly DC bus and this is AC bus. So this type of microgrid is called AC-DC microgrid or hybrid microgrid system. Next, type of disease. Different type of disease are Doubly-fed induction generator or DFIG, photovoltaic type renewable generators, micro turbine, fuel cells, storage battery, biomass, tidal, wave, geothermal, and hydroelectric. Wind and solar power generation mainly more advantageous. Basic components in microgrids. On the another side, local generator. What is a local generator? This is thermal energy sources, the diesel generator. And renewable generator source, generation sources, wind turbine, solar, fuel cells, etc. Another section, consumption, energy storage device, point of common coupling, and last, control units. The control units control the overall systems for high efficiency. Importance of harmonics for power quality. This is the important issue in microgrid systems. Why we control harmonics? Electrical system loads are increasingly becoming sensitive in nature because of the increased use of power electronics and computer control device. Maintaining stipulated quality of power as recommended in IEEE 1547 IEC EN NRS specification has thus become mandatory. Harmonic elimination therefore is a very important issue is respect of the operation of the microgrid systems. Undesirable effects related with harmonics. This is the very important topic. What is the undesirable effects related with harmonics? And this section we discussed about what are the problem and problem causes. Suppose example, power interference. This is the problem. And what is the causes? Harmonic noise. And PMU flow meter, smart meter malfunction. What is the causes? Harmonics. This is also harmonics. Capacitor failure. This is the problems. And what is the causes? Harmonic resonance. Computer malfunction. Harmonic distortion similarly. Blinking of incandescent light. This is also transformer saturation. Causes this. This is the causes. Circuit breaker, relay tripping, causes inductive heating and overload. Conductor failure, inductive heating. Electronic equipment shutting down, voltage distortion. Motor failures or overheating. This is also voltage drop. Transformer failure, inductive heating. This is the undesirable effects related with harmonics. Power quality issues. The modern power quality issues are electrical noise and harmonic distortion, grounding. Another issue, voltage sags, swell, flickers, spike, transient voltage and currents, long duration voltage variation, such as blackout voltage fluctuation, power quality or power frequency variation, voltage flicker. Power quality determines the fitness of the electrical power. This is the important sentence. Power quality determines the fitness of the electrical power. Next, power quality parameters. First parameters, frequency. Our frequency 50 Hz or 60 Hz. Next, voltage variation. Suppose this is the high voltage or this is low. This position low and this side high. This is the power variation. Next, voltage flicker. This is the voltage flicker waveform, and this is for voltage dips, where 0.1 to 0.3 voltage sag condition, and this range or this section is called voltage sags. Another parameters, interruption. Interruption 0.1 to 0.3. This is the voltage interruption part here. In this section, no voltage. And next section, temporary over voltage. This part mainly, this section, temporary over voltage. This is the normal voltage. In this position, temporary over voltage. And next, unbalance. In this section, three-phase unbalanced systems, RYB unbalanced system, 0.1 to 0.3. Another section, harmonics. This is the harmonics waveform, distorted waveform. This section, harmonics waveform or distorted waveform. Another section, voltage swell, 0.15 to 0.25. This is the voltage, this position voltage swell, because this position voltage magnitude is high, voltage magnitude high, and this is balanced voltage swell. And another, this position in this section, 0.15 to 0.25, unbalanced voltage swell, unbalanced voltage swell. Next, voltage fluctuation. This is the normal period, fluctuation period, and have again normal period. And this is the grounding and voltage spike. This section, voltage spike. So next, the wind turbine generator types. Mainly 4 types of wind turbine generators. Type 1, induction stall, squirrel cage induction generator. What is the advantage? Robust and simple. And what is the disadvantage? Low efficiency, flicker, no reactive control. Second part or second section, induction rotor current control, RCC type of induction generator. Advantage, variable speed, fast control, low harmonics. And what is the disadvantage? Middle efficiency. And this is the architecture. And doubly-fed induction generator or DFIG. What is the advantage? Variable speed, more efficiency, reactive control. And disadvantage, mainly harmonics. But only 25% of harmonics output power goes through the converter. Only 25% of output power goes through the converter. And another section, induction or synchronous full power. And the advantage is variable speed, reactive control, fast response to grid abnormal condition. And what is the disadvantage? More expensive. Harmonics, 100% output power goes through converter. The wind turbine generator types, 4 types wind turbine generator. And what is the basic idea of DFIG? This is the DFIG architecture. This section, rotor. This is the rotor section. And this is stator section. Stator is directly connected to 50 Hz microgrid. And rotor side connect one rectifier. This is AC to DC rectifier. And in this section, rotor side controls. Mainly this controller control the harmonics and power quality. And this is another DC to AC converter. This section directly connected to microgrid, and this is the DC link, mainly battery or capacitor side, balanced the system. And rotor is owned. It has 3 winding. Stator has 3 windings. Stator also 3 winding RYV. Induction machines look like a transformer with a rotating secondary. Conventional DFIG with wind. This is the architecture. Conventional DFIG with wind. In this section, this is wind part and this is the turbine part, and this section mainly gearbox and this own rotor induction generator or doubly-fed induction generator, because stator side connected with microgrid and rotor side connected also microgrid, but through inverter and rectifier. And this inverter control DFIG side controller or rotor side control inverter. This is mainly control harmonics, and this side rectifier is called grid side rectifier or grid side controller section. And this is the battery section, and this is wind speed or speed control section. This is the speed control section. So conventional DFIG with wind, And basic concept. What is the basic concept in this section? What is the slip? Slip equals to omega s minus omega m by omega s. This is the simple equation. Ns minus nm by ns, where ns equals to 50 into fs by p, where p equals to poles, number of poles, and fs equals to supply frequency. Mainly, we can manipulate to get nm equals to ns into 1 minus slip, or omega m equals to omega s into 1 minus s. The induced rotor voltage having frequency of omega r equals to, which is omega r equals to omega s minus omega m. And this is the important section. Observe 3 modes of operation, mainly DFIG modes of operation. This is the DFIG modes of operation, where subsynchronous modes of operation, synchronous modes of operation, and supersynchronous modes of operation. So first case, subsynchronous modes of operation, which is satisfied omega m less than omega s, or omega r greater than 0 or s greater than 0. Another part, synchronous operation or synchronous mode of operation, which is satisfied omega m equals to omega s, or omega r equals to 0 or s equals to slip equals to 0. Supersynchronous mode of operation, where omega m equals greater than omega s, or omega r less than 0 and s or slip less than 0. This is the main section for DFIG part. And harmonic elimination in microgrid. So why microgrid? What is microgrid? Generation of microgrid and importance of microgrid in importance of harmonics in microgrid, mainly. Harmonic elimination in microgrid. This is one of the technique. And what is the technique? The lower order harmonics are individually eliminated in each DFIG output, but the higher order harmonics are eliminated in such a way that the harmonic generated by one source is eliminated by the other after generating the same order of harmonics in opposite phase. So advantage of microgrids. What is the advantage of microgrid? Microgrid is a way to integrate wind, solar, and hydroelectricity. Second advantage, microgrid is capable of operation in grid connected modes, standalone modes, or both. By proper maintenance, microgrid improves the ability of power quality, system efficiency, economics, and resiliency. During emergency, power shortage period or power interruption period, the microgrid provides complete solution of supply the power in the main grid. Microgrids can separate and isolate independently from the central grid during disturbance, and it is controlled by locally by the society. And another advantage, carbon dioxide emission reduced. And what is the disadvantage of microgrid? The main disadvantage of microgrids are many disadvantages, but here we discuss. Due to different disease, the voltage required, frequency and power, that is resynchronization with utility grid. And second disadvantage, sometimes more space required due to battery bank. Installation cost is high. Reverse power flow, bidirectional power flow at low voltage may lead to protection, coordination, complications, unpredicted power flow patterns, distribution of fault current, and voltage control. Stability issues is the main factor for local oscillation. Small disturbance, stability, transient issues, and this is the importance disadvantage. Low inertia in the system can lead to severe frequency deviations. Low inertia in the system can lead to severe frequency deviation. And next section, our discussion. Conclusion. What is the conclusion in this? What is the conclusion? Problem addressed, actually compensation of grid harmonics by DFIG rotor switching. We can apply 180-degree conduction mode of operation, 120-degree mode of operation by switching purpose. Another section, bipolar switching, unipolar switching, any type of switching you can apply. Operation of modified compensator in UPPC mode addressed various power quality problems. You can modify the power quality, that means sag, swell, flicker, harmonics, any type of power disturbance you can solve by using UPPC. Minimization of voltage related problem, active and reactive power compensation. And this is the main section. What is the future works? Our target, microgrids to conversion or convert smart grid, microgrid to smart grid, and unidirectional, that means unidirectional to bidirectional, more efficient by using PMU, smart meter, flow meter, etc. More secure with Wi-Fi password protection. Application of high technology products like nano batteries, nano solar cell, nano super capacitors, and nano fuel cells. The microgrid storage capacities are increased and makes the microgrid simpler, smarter, etc. And this is the smart grid. So what is the architecture? Smart grid, future smart grid section. This is ROIB power line, and this is smart meter, consumer 1, 2, 3, ... consumer in. This is the harmonic section. This is flow meter, PMU meter, and another section, power controlling device, mainly FATS device for sensitive load. And this is the microgrid section. And for flow measurement, suppose bidirectional, this type of microgrid is called smart grid system. Another future work, or using the power electronics FATS, inverter operation, PMU, smart meter, bidirectional effects, storage device, and advancing automation, the microgrid makes more popular like smart grid. For PV system, the partial shaded problem are the major issue. So primarily our targets to solve the problem and utilize the maximum purpose. In future, the PV power are directly used in stability and control the fuel cost, also for wireless power, wireless mobile charging, space solar power application. It is technology benefits. In a single sentence, technologically, the solar will lead us to a brighter future. So, future developing the FATS device, SBC, STATCOM, DVR and UPVC can improve the active power section, reactive power section and voltage variation, harmonic polluting loads effects with high performance, low loss, cost effective. Future research, it can be modified or for simplicity, reliability, usability and controllability. And another future what? The harmonic elimination also can be improved by improving the switching technology, mainly switching technology, controlling purpose. In future, our investigation obviously gives the high performance microgrids with the overall voltage TSD in the microgrid because decreases the system loss, improved DC link voltage, increases the completing speed and solves the vital commutation loss. Also improve the electromagnetic interference and the most sensitive harmonics with high frequency inverter switching techniques. So thank you.